Good afternoon. I hope everyone's well and enjoyed lunch. My name's James Relph. I am from Capgemini. I'm a platform engineer. I'm part of the UK Digital Platform Engineering Unit. We work across a number of sectors, different tech, heavily involved in the UK public sector. This talk is called Show Don't Tell. Show Don't Tell is kind of author trick about letting people kind of feel and discover things themselves rather than trying to explain it to them. It comes up in books, it comes up in films quite a bit as well. And actually, I think it kind of comes up quite a lot in terms of kind of software development. So I joined a fairly major project about 2.5 years ago now, and was instantly told that I don't think continuous delivery is suitable for us. Releases once every 2 weeks, outside of working hours with change windows, and there was a lot of work, a lot of manual steps that went into them as well. And we could have had that argument with them that, look, Netflix does this, I'm sure you can too, but we'd have lost, to be honest. So what we decided to do was to start working and kind of slide some things in to convince them that they could do continuous delivery. So what I'm going to cover is some of the techniques, some of the tools that we used to enable that process. And we actually went from this kind of once every 2 week, big bang kind of release. Our releases on average, they'll take 50 minutes. There'll be multiple teams releasing per day. And we've been pretty successful. We're not fully there yet, but we've definitely made some good progress. As a bit of background, there were lots of teams involved in this process. It started off with around 12, went up, it fluctuated slightly, delivering lots of different components. Teams were of different sizes, different skill sets as well. And an interesting one that we've come across has a bigger effect than many people realize, lots of different commercials. So some teams who were on fixed price, some teams who were on time and materials. And that has a marked difference on the kind of priorities of those teams. And we've come across that quite a bit. In terms of our team, I was on what was called the core DevOps team, which is probably a bit of a misnomer. But effectively, we were an enablement team. So if anyone's read there's a great book by Matthew Skelton and Manuel Pace called Team Topologies. They talk about the various team types, and one of those is an enablement team. And we kind of floated around a bit working with the other teams on the project. We paired with their people who maybe didn't have the right skill set to deliver certain things. And we had kind of, we've had good success working with these teams. And a lot of the success has been that we've built these good relationships. So in terms of building trust on the business side, there were 3 main areas we targeted: reducing cognitive load, picking the right tools, and prioritizing for evidence and metadata. So the bit I'm going to concentrate on most is prioritizing for evidence and metadata. It's not that that's the kind of most important, it's just the bit that I was more involved with. Things like reducing cognitive load, again, the Team Topologies book is really great. If you have a read through that, it gives you some good kind of tips and a good way of kind of evaluating how teams are working. Just briefly on that, one of the reasons we spent quite a bit of time on it was that, one of the problems the business had was that they couldn't deliver quickly. And if we came in and said, it's great, you can do CD, we'll get you there. Their first response would be, we can't even deliver the features we want to deliver now. How on earth are we going to do something fancy and new and shiny? So making it easier for the teams, reducing the amount of work the teams had to do, give them more bandwidth to deliver the features, and that kind of opens up the business to new ideas and actually saying, yeah, okay, perhaps we can do something new because we're delivering what we need to deliver. Also, if you take work away from the teams, there's less things that they can break, less things that can go wrong. And there's many different forms of doing this. We had shared patterns, we had guilds, SME teams, enablement teams like ourselves to work with them. One of the things we had a lot of success with, we were in a Kubernetes-based platform, and we worked quite hard on developing kind of sidecar patterns early on. So this was around about 2 years ago that we started. So this is the kind of thing that currently you might work with, something like Istio, something like AppMesh. At the time, they were still quite new. It was kind of Linkerd version 1. Istio was still quite kind of fresh. So sidecar patterns was something where within a Kubernetes pod, we could start taking work away from the delivery teams and standardizing it. So for instance, this is a common pattern we use where we moved all the TLS termination into an Nginx reverse proxy within the pod. We moved secret management into a little sidecar, which kind of worked with our secret store, which in our case was HashiCorp Vault. And this was a shared pattern. We developed this once, and then we shared this with all the teams. And the great thing is that none of the teams really like working with certificates. It can be a bit faffy. You know, we rotate our certificates quite regularly. But we could just take this and we could give it to one team, working with Tomcat. That's fine, take some work off them. But another team who are working with React, again, we could give them the same tools. And actually, all they have to do is make sure that their container's listening on localhost, the Nginx proxy will forward to it. And it's actually quite simple. We had a lot of success with that kind of thing. So that was one of the things we did to reduce load. And the advantage of that as a pattern is it's something that's quite easy to slide in. It's not something like kind of Istio where you need to do a big kind of platform change. You can actually just get a few teams starting to use this kind of approach and work from there. And that's probably one of the other things we took a lot of effort to avoid is actually avoiding kind of big bang tooling changes. Avoiding anything where it was kind of like, we can spend 20 weeks getting this in. And yes, it will be the best way to do it, but it won't necessarily be the quickest way to do it. So we looked at things that we could slide in without having to do these big bang changes, things that had this graceful glide in. Also kind of picking where you could fight inertia as well. There were some tools that they were installed and they were kind of working well enough. We could have argued that we could do things better. But it wasn't worth the fight. You know, we were basically looking to make it better. We didn't want to make it perfect to start with because we'd have still been working on it now. We wouldn't have got there. So it's an example of this kind of graceful glide, and the tools we kind of picked to focus on first were things like Helm and things like Serenity. So Helm is a Kubernetes package manager. It lets you wrap your Kubernetes definitions up into a single artifact. And the nice thing about Helm is it doesn't really take much. There used to be a small program to install within Kubernetes called Tiller. But you could put standard Kubernetes definition files within Helm. You didn't have to change much to start working with it. Serenity, quite similar to Serenity, is a BDD framework for testing. But within it, you can use your standard testers. You can use JUnit, JMeter, Selenium, various other things. So they were easy to get in. Something like Istio, on the other hand, we're still trying to get Istio in now. We think it's probably the best way to do, but we're going back and forth with the kind of platform team. It creates more work for them, and it's also one of those things that to use it properly, kind of all the teams have to start using it at once. So that's something that where we kind of prioritize for these things on the kind of left of there, the kind of things that were easy to kind of glide in to the project. And it was similar with kind of fighting inertia. I'm kind of a big fan, as my colleagues will tell anyone who asks, of Concourse from Pivotal, which is a CI/CD tool. I think it's a very elegant tool. I'm not a fan of Jenkins. On the other hand, Jenkins was in the environment. It worked with the systems that were in there, and it was already well integrated. So, yes, we've come back, we've looped back, we're trying to get Concourse in now. But at the time, stick with what was working. It wasn't worth kind of that fight at the time. So those were the tools we initially picked, with a kind of honorable mention to Chart Museum. So like I said, Helm is a package manager for Kubernetes. Chart Museum is a really straightforward tool to use. I used it with that instance for about 2.5 years, and it just lets us store our charts somewhere. It's a central repository for Helm charts. Really quite effective to use that. That did form a main part of our pipeline in the end. So, root causes behind the lack of confidence. When we first got in there, deployments were hard. Rolling back was harder. Actually, that was one of the things that led to the reticence to move more quickly, was if something went wrong, it was a big issue to fix it. Integration tests were long and complicated. Environments often required manual aligning, so we had Slack channels where people were basically saying, right, we need to do a test. Who needs to put their previous version in? What's currently in prod? How do we need to roll this back to make it kind of work so we can run our tests? Our config was also hard to manage, and misconfiguring config had caused outages in the past. So that was often the case where something would go into production and there'd be a reason to roll back. They'd roll back the actual application, but they'd forget to change the config back to how it was previously. They'd put in the previous application and things would break. And then this was the big thing. they'd had a kind of fairly complicated pipeline. I think when we had a look at it when we first landed, one of the bash scripts in the Jenkins pipeline was 800 lines long, which is too big for bash in general, but especially when you're trying to have a nice, simple kind of pipeline to work through. And what this meant is that people fell back on processes that gave the illusion of control. So the business thought, we've got problems. Let's put more kind of rigor in there. Let's put more kind of manual steps to control our production environment. So you had this vicious circle of a complicated pipeline made things slower, so it made everyone make the pipeline more complicated and the manual steps more complicated. And it went round and round like that for a bit. So moving on to what we did with Helm. Helm gave us, by default, the thing Helm gives you is it gives a packaging for a service at once, really. We could put all the microservices that formed a deployment into a nice artifact that we could move through the environment. We kind of extended it for a little from there as well, so we also packaged all the config in there. And what that did was it meant that as we moved that through the environments, we were sure what config was going to go into each environment, but also if we needed to roll back to a previous version, it by definition rolled the config back as well, so we kind of got rid of one of the problems we'd had previously. We went a little further and started packaging metadata about the service so that we could kind of like prove to the business that what we were doing was kind of safe and that we were kind of having the results we told them we were having. And it's strongly versioned. Helm uses Semver for versioning and has provenance files. So when you create a chart, you can sign the chart. You store the signing file alongside the chart within Chart Museum. So when we go and deploy it, we can actually say, right, this is definitely the chart that we have run all our tests on. We know no one's fiddled with it since, so we should be good. Helm itself is quite straightforward. In some ways, we used an umbrella pattern where we had a chart at the top, which basically didn't have anything in it, didn't have any objects to deploy, but it just said, right, I am the full service, and this full service is made up of these subcharts. So in this case, this umbrella chart has 3 microservices underneath it that we were going to deploy. There's also a common chart in there, and we can pull that in. That can be a central chart, and common charts, they've been renamed in Helm 3 to kind of library charts and are officially supported now, but common charts was something where we could put boilerplate code. So again, this goes back to kind of reducing the cognitive load. We could actually write some of our Kubernetes definitions once, put them in a common chart, and everyone could reuse them. And if we needed to fix them, we could do them in one place and version that. Everything kind of versioned separately when you're dealing with Helm charts, and this kind of uses underlying kind of Kubernetes kind of operations. So if you just update one of the services in there, so if you take the second service from 1.1.2 to 1.1.3 and deploy the entire umbrella chart again, the only thing it's going to change is the bit that's changed. So you don't have to worry about kind of breaking this down and saying, oh, we only changed this bit, we'll just do that. So within the umbrella chart, there's a few standard Helm files that we had, and the requirements.yama, which was to get the subcharts in. The other files here are the ones that we put in there. And if you have an _.yaml file within Helm, Helm will build it into the chart, but it won't do anything with it. It'll read it, but it won't kind of create an object. So the first 3 there, the dev, the int, and the prod, are where we put our kind of variables for the different environments. So we built them into every chart. So when a team was saying, this release needs to go through all the environments, they built all the config into the chart in a kind of format that they made. It didn't matter what, it just meant that they could play that into their template files. So this is a quick example of some templating within Helm. The bit on the left would be within the values file. So for instance, the dev or prod files. For instance, this might be a prod one where we are doing kind of HPA auto-scaling. We're going to scale the pods based on load. The bit on the right is how you then kind of plug these into a template. So you can see within the curly brackets, you just kind of reference the variables that you've pulled off there. And you can see target CPU utilization is scrolled off, but it's fairly easy for teams to start going with this. The templating within Helm gets quite kind of like complicated, or it can be if you want to. You see one of the top ones is we've got a if equals, if that value is true, it will play this in and not. So you can have kind of if blocks within your templates. So you can start doing kind of quite powerful things, but you don't have to. You can start with just simple kind of variable substitution in there. The common charts are effectively a kind of an extension of this. So within the common chart, we have boilerplate files in there effectively, and we will specify kind of a bit of code that we're going to use. And then when we want to pull that into any of the charts, we just reference that code and we pull that in. So the service charts themselves, again, they had the same kind of environment values files in. We would have those for dev, integration environments, and prod. There might be some things that you want to have on the umbrella chart level. So for instance, your logstash kind of endpoint, which is going to be the same across all your services. And then there might be some variables that you only want to pull in for an individual subchart. So you've got that flexibility there. And like I mentioned with the common chart, that was kind of boilerplate stuff. So in Kubernetes, we had boilerplate for deployments, for ingresses, for services, proxies, things like that. And it just meant that, teams didn't have to do them themselves, and it was harder to break. If you're just reusing something everyone's already using, there's less chance of it going wrong. One of the files that you saw in the service ones here, and it's actually in the umbrella ones as well, is this release notes.yaml file. And that's simply a YAML file where we dumped the Git history for any service that we were putting in. So when a team was going to create a chart, they would tag their repo, and then when they made their next one, they'd do another tag, and they'd basically pull out the Git history between those two tags and play them into that file. And what that let us do later on is basically collate all that history together. So every time we released an umbrella chart, we had all of the commits that made up that release, both at the subchart level and at the umbrella chart level. We did have to put a bit of kind of Git hygiene around that. So we had a pre-commit hook within Git that made sure that the start of each commit message was a ticket number, so that actually the commits were kind of meaningful, because, to be honest, otherwise half of my commits tend to look like that, and the other half tend to look a bit like that. So that's not uncommon for me. But once we had that in, we effectively, each of those charts had a nice kind of list of all the commits in it that had made up that release, so we knew what was going on. That's that nice extra bit of metadata that we were saying there. And our pipeline, when it ran, basically hoovered those all up, it collated them, it deduplicated them. So it meant that whenever there was a release, we could post in a Slack channel, we could put on Confluence, right, this release is going in, and we know that these are the releases, these are the commits that went into it, these are the tickets that linked to those commits. So we could have links so that anyone from the business could click on a link in a Slack channel, see the Jira ticket, see all the kind of commits that had made it up, and because we were kind of signing these charts as well, there was a degree of confidence there that actually what was going into production was what people thought was going into production, which was kind of a big move for us, to be honest, and went down really well. One of the other files that we played into charts, and this only went in the umbrella chart, this is kind of an example, and there's a lot of bits in here that really it's just an idea. This is our own format, it's just something we made up, it's just kind of a YAML file. But this was basically, the teams could say what tests they wanted to run. So they could specify their tests, and we would go and run it for them. And there are things in here like, where our tests live, what feature files we want to run. And down at the bottom, things like dependencies. So we could say, right, this chart that we want to run here, we want to run it against Team 1's version 1.2.3. Team 2, we'll go for any version 1.5. The tilde means it ignores kind of patch numbers. Or Team 3, actually just anything bigger than version 1 we'll go for. And that was useful when we get into doing the testing, that we gave the teams the control to do it, but then we could automate it. So we had a set format that we could work with. So going on to the original pipeline, this is kind of the issue that we had with it. There was a big blob of config stored in Git at the bottom that floated around. And then lots of environments. There was actually, like I said, we ended up with about 16 teams working on quite a few different components. I've put 4 up there, but what you can start seeing is that in the integrated environments here, where people wanted to do integration tests across the different products, it didn't match what was in prod. So people would be trying to test their version 2, and someone else had version 3 in there, and they got to prod and something didn't work. And the solution to this was basically decided to be, let's add another environment, which was a practice environment, which was supposed to be basically always the same as prod. But again, that was just something else to kind of manually manage. It needed people to kind of curate it to make sure the right things were in there. And it didn't help. It just made things longer, to be fair. It made that whole kind of feedback cycle longer. So we were kind of coming on as a bit of a new project. We had a nice kind of quite microservice architecture, so the old one was quite kind of deeply coupled, so it didn't help on that front. So what we decided to do was kind of build something new. So we built something called the core pipeline. And in this kind of system, we effectively had, all the teams had a dev and feature environment, which they could play around in, do quick tests, things that they could have rapid feedback on. So they could run, any test they wanted to quickly, see results quickly. They were working against stubs in those environments, so it was quick to run tests. They didn't have to rely on anyone else. We then effectively had this kind of virtual release point, which is when the teams had passed their tests, when they had a release that passed, they tagged their chart with a little bit of metadata at the end. So Semver supports adding metadata to the chart name. So in our case, we did plus RC for release candidate. And that pipeline watched Chart Museum for plus RC charts to land. So when one landed, we knew what we wanted to do with it, which was to basically deploy it and take it through the integration environments and get it ready for prod. And this basically was the kind of like approach we used. And it took away all these manual steps. So past, their dev and feed, the teams didn't get involved. It was all kind of automated. So if we had a release where, for instance, Team 1's version 3 hadn't made it into prod, and Team 2 wanted to test their V2, we'd automatically roll back Team 1's version 3. Because that was what Team 2 may have specified in their tf.yaml file they wanted to test against. What teams could also do is say, actually, this product, the bit we're putting in here, isn't going live straight away. This is going to be dark release, so we want to test it against version 3 Team 1's. Just to make sure it works. So teams had control of this through the tf.yaml file we built into the charts. And actually quite frequently what teams would do, and what we kind of encouraged them to do, was to test against multiple versions of other teams' releases. So Team 2, they could specify, let's test against Team 1, their current version, their next version. And we kind of devolved this control kind of back to the teams, but automated the kind of whole process. We did have a few other kind of bits of metadata we put onto the kind of charts. So this one, in early delivery, some teams might only want to go into early integration, do a quick test. So we had things like +int. We have kind of discouraged teams from doing that. We've been kind of quite big on trying to get teams to do a hello world. So even if they're not ready to go live, actually just run something all the way through the pipeline into prod. We'll just treat it as a dark release, so we won't expose it, but let's run it all the way through. So it's possible, but we kind of tried to get people away from doing that. And the other thing we've been quite big on is doing kind of canary releases. So this is where we will deploy 2 versions of the charts into the environment. And we'll send a certain amount of traffic to one version, the rest to the original. And that's worked really well. That's been something that, again, it's quite easy to do from our point of view because we are packaging anything into these charts. The whole process of rolling forward, rolling back, using Helm is a lot simpler, especially with all the extra stuff we've built in there. And we actually use the canary process for our dark releases as well. So the teams are used to doing canary releases. We don't want to give them another process to do. So if they want to do a dark release where they put something in prod, make sure it works, but don't expose it, we basically say, right, do a canary, but set it to 0% of the traffic. So they release it, it works. And then, if they want to kind of increase and actually turn it into a proper canary, they just up the percentage of traffic they send to it. And I think the main thing kind of I want to kind of highlight on this point is this wasn't a case of this one, I kind of chuck it over the fence, right, we've done some work, now you have it, and you go and run the test, you go and do the deployment. We turned the core pipeline into a product. So we kind of like worked hard on making sure that the teams were putting the right information into their charts to make sure we could do all the orchestration for them, and they were putting metadata in there to ensure we could prove to the business that we were doing it right. But we weren't controlling it. We created it, but we left it for the teams to put that in and to tell the pipeline what to do. So what we kind of achieved on that, well, first off, the teams liked it. I mean, anything that takes work away from the teams tends to go down well. I mean, originally there were a few kind of engineers on the team who I think were a bit kind of, maybe they wanted to play around with some pipeline stuff, but to be honest, when we spoke to their project managers and said, we can do the work for you, and then it'll be our fault if it goes wrong. It's surprising how many project managers like it when it becomes your fault if it goes wrong. So that worked well. And we also had several assurance levels. The charts can't be changed between environments. We know exactly what charts were run against what other deployed versions. So we know when we did the test that it was version 1 of Team 1's tested against version 2 of Team 2's, version 3 of Team 3's. And we know the config wasn't changed because the config was built in there as well. And in the end, it removed a significant number of manual steps. We set on this format, and actually we could automate it. And that was kind of a big one, because manual steps are just more things where things can go wrong if someone's not paying attention, if people aren't aware of some changes that are made. And that all led to a massive improvement in business confidence. And I think the best thing from putting this in place was that we were probably about a year in, maybe not quite that much, but we'd put a lot of the kind of groundwork for this in. And I went on holiday for 2 weeks, and I came back, and all of a sudden everyone was deploying in the middle of the day as though that was fine and normal. And this was kind of like a business situation where they'd been had these out-of-hours change windows, and all of a sudden there hadn't been a big fuss. People had just decided, yeah, we can do this, so let's kind of start pushing in the middle of the day. We can roll back easily. We know what's going in there, so it's not a big problem. And it was really nice to see that. Of course, this only works, if our tests are reliable and fast. So we had kind of a great test team that we worked with, different company entirely, but like I said, it was important that we all had these good lines of communication, and we worked with the other teams that were in there. And they were kind of big fans of the Serenity framework, BDD framework, and the nice thing about this is it wrapped all our tests within this framework. But we could include whatever tests we wanted in there. So we were using JMeter at the time, replacing that with Locust, things like Selenium, Postman in there as well. Things like our accessibility tests also built in, and there's kind of a big push for that, especially within government. Deploying testing in Kubernetes can be a little bit interesting, and Kubernetes has a tendency to move things around when it thinks it needs to, and obviously if you're running tests, that can really mess things up. So we deployed with controllerless pods to kind of mitigate that to some extent. And kind of as I said, we were offering these things as products to the teams. So which tests to run and how they're going to be run is pulled back from that tf.yaml file that I showed you earlier. So it's not us kind of deciding to run how the tests run or the test team. It's the delivery teams that are deciding how to do that. And the other thing we spent quite a bit of time on is kind of one test, one pod, which was basically, rather than running a lot of tests serially, one after the other, we had a massive kind of like scattergun approach to firing tests. We fired off all our tests, sometimes as much as 800 at a time. And they were kind of self-organizing within the Kubernetes cluster. You could run this locally. You could run it within Docker for Desktop or Minikube. And it kind of scales quite well. So this is a whole other topic in itself. It's really quite interesting how this worked. But our pipeline would basically pull in the tests from Git that were specified in the charts. We'd kind of right-size by type. So we'd have a rough idea how big a pod needed to be for UI tests, for performance tests, and for API tests. So some would have more memory, some would have more CPU. And we'd basically fire up a load of pods however was needed for all the tests that we're going to run. And now Pipeline basically then let the tests get on with it themselves. So all of the pods that we've just created, they know whether they're UI tests, they know whether they're performance tests, whatever. And they basically go and have a look in the test repo. They pull back the tests. And they start writing into a config map within Kubernetes and saying, I'm running this test, and I've finished it. And it meant that we could run things kind of quite in a kind of parallel way. It kind of run things quickly, make sure the cycle time to teams getting this information back was fast. It was kind of this self-organizing kind of cluster of pods. When the last one has written, we know the pods in the config map, they've written in there how many tests there are to run. When the last test finishes, when it gets to the end, it basically then triggers the collation of all the tests and outputs the results to S3. So there's a lot more to that test framework, but just to give you an idea that this is kind of, taking this whole kind of parallel running of tests. The test team actually been quite keen on this because of how this also tests other things as well. It's kind of almost like a stampede of tests they can create, and that's given them some extra kind of metrics as well. And in the end, we combine this with the release notes.yaml data, all the Jira tags that we had before. We put this in Slack, we put this in Confluence. And this kind of visual output that you get from it. So, you get a view of what tests have passed, how many tests, any tests that have failed. And we have Confluence pages, Slack pages, with these test results on for all the components, what they were tested against, and all the commits that were put against it. And that's kind of how we did it, really. We just put all that data there so the business could see we were doing it safely, we were getting the results they wanted, and it was kind of like it was repeatable, and things like the provenance files meant that we had a level of assurity on that, and that's kind of that's how we got to that end result where they were letting us deploy regularly. It wasn't us that forced the issue, we just showed them that they could do it, and actually it turns out that once people realize they can do it, they often do. And that's it, so thank you very much.
Okay, questions around challenges. So folks, what kind of challenges have you all seen about this kind of stuff that you're curious about?
Yeah, so I guess I see a lot of people have challenges with Helm when it comes to like orchestrating multiple charts together and doing them in particular order so that they all get built out in the right ways. What have you found to help with that and be successful?
So first of all, does anybody other than James have a comment or suggestion on that? I guess one thing, so I don't have a lot of personal experience with Helm in particular, but like one of the things in terms of like ordering with like say infrastructure as code and those kind of things, is I try to figure out if there's a way to design stuff so that it doesn't need the ordering, if that can be made so that they're a little bit more, idempotent is not the right word, but a little bit more kind of like that. So that's an aspiration. It's not always possible, right? So there may be some other techniques.
I was interested in this talk because we have kind of a problem. We're not using Helm, and I was interested in kind of how you're solving it. But in our problem, we have numerous microservices, about 30-some, that each of them create a build output that there's a kind of fan-in and aggregation pipeline that makes like a manifest of stuff that's kind of similar to a Helm manifest, I guess. And so we put it all together and we put it in an integration environment. It runs functional tests and then promotes for exploratory testing and eventually gets released. But there's problems with that approach for us in that if there's a problem with one of those, right, we don't really have a good, we drop everything and try and fix it. We don't have a good way to go and roll back one. That takes someone manually going to do it. And, it's just been a frustrating problem for everyone, right? So I guess that's the problem that we've had, but I'd be curious if anybody else has the same kind of maybe general guidance on how to approach that.
So I'm curious about that one too, but just I just want to double check whether you have any response to Paul's question. We don't want to not let you answer, right? We just wanted to give other people opportunities as well.
Yeah, I know, but I do kind of prioritize the mic or things like this. Yeah, architecture basically. It was we had the ability to go kind of quite microservice, kind of quite 12-factor. So to be honest, the thing was it didn't matter. We could just splat them in, and it generally worked. And the thing was, once a few teams start doing that, the ones who can't do it start being the ones that everyone points at and says, "Oh, you're doing it wrong," and then they change and align, and that's how we kind of solved that. Really, it doesn't matter which order we do because Helm really is bad at that. It's not designed for it.
I'm seeing a lot of challenges around turning over this concept of infrastructure as code in a historically ops versus dev environment, right? We had some centralized teams, and then turning it over to the dev teams, and so they start immediately just like doing everything all in like a single CloudFormation template or a single Terraform template, or they combine everything, and so you end up with these complex systems and rebuild a monolith by looping in your infrastructure code along with your application code. And I thought it was nice that you kind of outlined, at no point did you talk about the, the underlying pieces that build the Kubernetes clusters, because that's done. That's separate. Everything else should be only focusing on what your service is doing and kind of separating those disciplines. So I see that problem a lot of different companies.
Can I respond with an opinion on the question that you asked? Okay, yes. proper protocol. What I've done on teams where we've done that thing you described of fanning in and then like progressing the things together is basically, rather than trying to roll back one one service or whatever, is to roll forward. So we would go back into that service that had a problem. If we wanted to roll it back, we would basically make a new build or revert the build or whatever of that, and then push that through. And so that's generally worked for the projects I've been on.
That's something that we have, I guess that's the default action, right, is to roll forward or go and do surgery on the manifest and make it go back. But, in the end, it makes for there's a huge gap that can create. And that's a problem of maybe tests need to be earlier. Things that are done at a end-to-end test could have been done at a component or a unit even level. So maybe that's really the core sickness. So that is cure that so you can more quickly roll back a service.
So just to make this religious, on mono repo versus multiple repos, like we actually just put a bunch of services together into a single repo because they had to be deployed together. So therefore they change together. Therefore, why are we getting the overhead of having to make changes across repositories? So we have similar challenges with some of our dependencies. And yeah, so I would say if they have to be deployed together, are they in the same repo? And can that just be treated that way rather than manifesting together? And then I would just say, to your point, is get people started learning how to do things independently, start putting stubs in some environments. That's what we started doing, and people freaked out because data they were expecting wasn't there. But they figured it out, and now more and more teams are putting stubs in the early environment, so everyone's starting to spread out a bit more. So those are our two solutions.
Cool. Just to raise up the next question of what kind of successes, if people want to share things they've done that are cool or interesting that they'd like people to know about, please share that.
Well, maybe one of the successes that I feel like we're getting to, we're not in the Kubernetes space, and so, but we do really struggle kind of with, I hear from you like, hey, we're microservices, but we deploy as a monolith. That's kind of really what I was hearing. And we're a monolith trying to decompose ourselves. And one of the successes I think we're having is finding those services or finding those applications that we can peel off that aren't dependent on that monolith. And they can then start this opportunity to deploy independently and grapple with what it means to, how do I deploy in a way that, doesn't make me dependent on the monolith, right? That's the thing they've got to grapple with. But as they do that, all of a sudden they realize, I'm free, And so as they solve some of those problems, then for us, all of the other teams, they want to come along. What does that mean? How do I decouple myself from the monolith? How can I get it so I can be a little bit freer? And the discussion, so I think that's a success of itself, but I think one of the things that another success is that as teams, they begin to think like, what is my deployable unit really? Why am I deploying with all of these other things? And I think it's helped us begin to refine and get tighter and tighter as to what's this set of things that are going to deliver value to our customers that we can ship independently and be able to deal with, hey, we need to roll back or do something different. And so we're at the beginning, but we're starting to see like some excitement and opportunity there.
I was also going to say one great thing about having a team that's been kind of struggling with having a delivery pipeline, no matter what it is when you get them on your side, suddenly they become the advocates for actually doing it. So this isn't my success, but it's the success of an old team before I started. They all got into a pipeline, and it was actually a documentation team. Heidi's not here. But there was a documentation team that I joined. They really got into an entire pipeline, and they realized how wonderful it was and how awesome it was. They then started telling every single other team about why it was important and why it was exciting. So just a thought that a big success is always when you get other people advocating for making the pipelines happen. So.
Yeah, so I guess I have a success story that might also touch on what you were talking about, and that is, when you have Helm, it's got tiers of charts like dependencies, and that's great for when you have like an application with like a dependency on a database. But when you've got like a group of applications that are dependent on each other, there's some tooling out there like Helm file, where you basically specify a list of charts and versions to install, and it kind of goes through them in not necessarily a strict order, but it's a good way to have like an umbrella chart type thing that's a little bit more ordered and specific, that lets you be very specific about versions. And you can also like template the templates of the Helm charts, so you can do some really interesting things about what versions are coming from where, and setting global variables where the Helm charts may not support global variables, and all sorts of stuff like that. So Helm file has made my life a lot better from working with groups of Helm charts that really need to be installed together.
One quick thing that was interesting, a bit of a side effect, and we don't quite have the full set of data on this, we are looking at it, but is that we think we kind of reverse Conway the architecture a little bit. When we start, so aware of Conway's Law, that the architecture starts mirroring the lines of communication within the business. Because we cut down the amount of kind of cooperation the teams were having to do at a release level, it actually made them start working kind of more independently. And we've definitely got the feeling so far that because of that, the teams have been a bit better at making sure that they can release independently. So we've had this bit of a virtuous circle where by breaking those links, we've actually improved the architecture somewhat as well, even further.
One of the things that maybe what you just said is jarred my memory about Conway's Law. I think one of the drivers to gather all our stuff together in a manifest is because really what we deliver is a single API. All these microservices underneath, it's not really visible to product. It's not really, they don't care, right? So they evaluate a release as this cohesive set of stuff together working. And maybe to tie in the success story, maybe one of the things that we've been trying to do is move things earlier and onto those individual project pipelines, and instead of doing full end-to-end tests, taking and making component tests that just stand up one service, and maybe it's immediate collaborators and dependencies, and shift functional testing earlier in the pipeline. That's gone well.
Cool. Let's throw into the mix any kind of comments and ideas on what we would like to see going forward around this area of kind of pipelines and this sort of thing.
Is there anybody that I should bring the microphone out to that doesn't want to walk up?
Start picking people out.
I'm going to pick on you, Mandy.
So I actually feel like Helm and tools like Helm are actually a smell that tells us that our actual underlying platforms don't have a simple enough interface. And so we simplify them by wrapping another DSL and try to simplify them. And then that gets too complicated, so we make Helm file to try and simplify that. And so I would like to see us take what we're learning from tools like Helm and Helm file and try and push as much as that back to the platform as possible. But obviously the difficulty there is to build an opinionated platform that you need for your opinions, you need an unopinionated platform. So it's hard to know when to push those things down to Helm, or to Kubernetes or your platform, and when to accept that you're going to need to address that complexity at your level. But I feel like we're not at the right spot that we should be, and we should be pushing more down.
Maybe to echo what you're saying, we go even further and do stuff like have code generators writing Terraform code because we want to target different cloud providers and bare metal, and it's just a ridiculous amount of work to try and make a generic description of multiple platforms like that.
I feel like I'm being a salesman for the team topologies book here. But there's a bit in there about things like thinnest viable platforms. I actually had a bit of a discussion with Matthew about the naming of that, but I think what I'd like to see is, we've currently got these big monolithic Kubernetes clusters, and they cause half the problems we've got. They work quite well, but we'd work quicker if we had something we could quickly stand up, quickly stand down, whether that was Kubernetes, whether it was some serverless frameworks around that. And I think I'd like to see the platforms, actually kind of platforms to some extent disappearing, and just kind of different products being there that kind of like, we have a team that works on a product that runs containers, a team that works on a product that runs some serverless stuff. Make light repeatable bits that can stand up and run the code, so we're not having to do all this management and working with big things that drive us in a particular direction.
Yeah, I think it's interesting that I think we have this ideal of a platform like a Kubernetes kind of thing where it's just there and we deploy our applications onto it. We don't kind of worry about it. But the reality is a Kubernetes cluster is a lot of work to maintain. It's a lot of, and you're constantly having to patch it and update it and so on. And so we have to, like one of the kind of current things I see in like blogs and so on is like how having one big monolithic Kubernetes cluster is kind of maybe an anti-pattern, and that you actually have to kind of think of ways to kind of break them apart and have multiple clusters. And that, I think, as somebody says, it's a smell, right? That like it's kind of the technology isn't really there yet. So hopefully in the next 2 to 5 years we'll see it get more towards what our vision is.
Thing. So one other thing I would love to see is us kind of accept that tools like Helm and pretty much anything that we call infrastructure as code shouldn't really be used as like a Turing complete programming language. And we should be focusing, like figuring out where the right balance of like keeping something dry and not. I feel like we just immediately go to like trying to be as clever as we can, and we lose a lot of readability and understanding, which is a big deal for people that are newer to it, more junior people, or people that are trying to cross-train from another team. And by focusing less on like dry and more on readability and like it being like you look from top to bottom, you know exactly what it does, we're adding a lot of value, more value than if we were just being clever and keeping it dry. So trying to get more people agreeing to that and focusing on that rather than padding our resumes and trying to be clever.
Like massive issue.
Oh, I've got one.
Oh, sorry.
So I was going to say, echoing a point on there, is that, programmers and engineers, you copy things. I mean, it's encouraged. It's called code reuse. We do it all the time. The problem is that they'll take an example that kind of works, and then they'll modify it to themselves. And if there's like 10 examples out there, they're going to pick the worst possible example. And so I was reading an article about this woman who was making a roast, a Sunday roast, cut off the ends of the thing and her husband said, well, why do you cut off the ends of the roast? He goes, I don't know, my mom always did it. So asked the mom, he goes, I don't know. That's the way my mom always did it. So they asked grandma and found out that she cut off the roast because she had a small pan. So you may be doing, and so they had to cut it down so it would fit in the pan. So you may be doing something in there without it documenting, of doing something to get around something particular in the application, and everybody else thinks that that's the way it has to be done.
Awesome story.
Regarding that story, how about waving a magic wand that all of the Stack Overflow posts have documentation on why they decided to actually make the example that way, so that the next person copying it actually understands why? That'd be like my magic wand.
Onto that, I would really like TTLs on Stack Overflow examples.
All right, one more.
On that topic, the most copied, most utilized Stack Overflow post was discovered to have a bug.
All right, well, that's it for our session. Thanks, everyone, for coming out, and great conversation. Cheers.